the shape of the
We
triangle or
learn
the
about
math?
triangles, I'm pretty sure preschool maybe?
Yeah, preschool.
Kindergarten, right? You start looking at
Probably
triangles.
before preschool.
Before preschool,
But
maybe
I'm
your
not sure. I went to preschool starting at age 2.
parents probably show you shapes, right? Your babies, the thing that hangs from your crib. So now we're going to go for reals, right? We're going to learn triangles for reals. But before we do, we have to go back to the basics. A triangle is a polygon with how many sides? Kelly? 3. Right? So our kindergarten teachers did us well. What else do we know? A triangle with 3 blanks, A, B, and C, is written as triangle ABC. Now, what word do you think I'm looking for? What are different names for these little corners? Do you know, Amanda?
Well, like 3 corners or
Corners, right? And I'm looking for like the official word for corners. Yeah. Vertices. That is the word.
I did say corners or vertices.
Oh, I didn't hear you. You're right. So one of them is called a vertex. The plural is vertices. Right, so that's so far so good. All right, so we're going to classify triangles by side. So by size, a scalene triangle has no congruent sides. All the sides are different lengths. An isosceles triangle has at least how many congruent sides? I see that I should put them up. 2. 2 fingers went up. Yes. Equilateral triangles. Amanda?
3 congruent sides.
Yeah.
It's impossible for a triangle to have 1 congruent side.
Well, it depends what you mean by 1 congruent side. These are all different, so yeah, I guess you're right. I don't even know what that means, but yeah, I guess you're right.
Like 1 congruent side?
You guys make everything hard.
Sorry.
It's okay. No, it's good. It shows you're thinking. I like that. Classifying triangles by angles now, we use different words. Yes, sir.
Is it even possible to have 1 congruent side in any shape?
You think about it, you let me know.
Circles have a congruent side. Circles have 1 congruent side.
Oh boy, circles have congruent sides. We got a long way to go. Because I have yet to find a side on a circle. But I'm back to my triangle. Back to the stuff we did in kindergarten. We're back. Look how we're back.
It's a curved line in
Acute
different geometries.
Triangles have how many acute angles? What's an acute angle? What's an acute angle? Let's answer that question first. Amy? It is a acute little angle that has less than 90 degrees. So how many acute angles are in an acute triangle? Holding up 3 fingers. 3, right? Hey, yes, ma'am. Question?
I was just about to answer the question.
Oh, okay. So 3. A right triangle has how many right angles? Amanda? 1. Can it have more than 1 right angle? What would happen? Whoops. You can't even make a triangle now anymore. Obtuse.
Without curves.
That's not even a triangle. So an obtuse angle has how many obtuse angles? Meaning an angle between 90 and 180 degrees. Joseph's holding up 1 finger. Equiangular. What does that mean? Allie? 3 congruent angles. All the angles have equal measure.
And that would mean that it's an equilateral triangle.
Well, at the same time, you could. Yes, that's right. Okay, so you guys know a lot about this already. I expect you to. So that's just to make sure we're all talking the same language. Or again, more of a vocabulary. An interior angle are the angles inside the triangle. Interior means inside 1, 2, and 3. Exterior angles are formed when the lines of the triangle are extended. So I've extended the lines here, and now they're outside. So 8 is an exterior angle. I extend this side. If I extend this side, 9 is an exterior angle. So if we're naming the different angles, right, our interior angles, I think we can see are angle 1, angle 2, and angle 3, because they're inside the triangle. Remember, middle of each one here, if you're following along, hopefully you are. And my exteriors, extend this one, angle 4, is outside the triangle. What's extending this one? Extending that one, angle 5. If we extend this side, angle 6 on the exterior, on the outside. So these other angles are outside of the triangle formed by extending the side. They're exterior. Yes? Nope. These are my exteriors. It's like they're right next to an angle that's inside. Right next to. these are not considered exterior. I mean, they are exterior to the triangle, they're outside the triangle, but that's not what we need. The triangle sum theorem, I think most of you know this. The triangle sum theorem states that the sum of the measures of the interior angles of a triangle is 180 degrees. Who's heard that before? Just a few? Oh, we all kind of sort of knew that. I'm going to try and just kind of prove it real briefly so that we can use this theorem. A whole lot of stuff going on here. Basically what you're doing is you get a triangle, any triangle, and I want to prove that the measure of 1 plus the measure of 2 plus the measure of 3 is 180. So what we do is we kind of draw this parallel line to AC. What? Just let me finish, okay? So we draw this parallel line, and first I'm going to say that 4 and 2 and 5, you add up those measures to get 180. A number of reasons, angle addition postulate, definition of what a straight angle is, right? So we can figure out how to get that to be 180. I also know that 1 and 4 are congruent and 3 and 5 are congruent. Why is that? Basically, look for the Z, look for, here's a backwards Z, tucked inside a Z are my alternate interior angles of parallel lines. Alternate interior angles of parallel lines are congruent. So that means this one and this one congruent, that one and that one congruent. Alrighty. That means that their measures are equal. That's what this is saying, right, by the definition of what congruence means. Now, I'm going to do some substitution here. 4 plus 2 plus 5 is 180, but since 1 and 4 are the same thing, I can put a 1 there. 2 I'm leaving the same, and since 3 and 5 are the same thing, I'll put a 3 here, and then I get 1 plus 2 plus 3. Proved. So now it's not magic anymore. We have actually proven why they're 180. Alrighty. So not all these examples are necessarily on the notes. So some are, some aren't. I don't think this one is. Oh yeah, it's on the bottom. Skipping around a little bit. So it's the example A on the bottom. It says find the value of x and classify the triangle. Well, one way to do that is to know that they all add up to 180. So that means that x plus 125 plus 20 is going to equal 180. So that means that x plus 145 equals 180. So I'm subtracting 145 from both sides. If I did it right, I'm getting 35. Hopefully I did it right. You check me. Is that right? So let's see if there's any way we can classify this triangle. How about by angles? Is this acute, right, obtuse, something different? What do you think it is, Joseph? It's what? Obtuse. How do you know it's obtuse? It has an obtuse angle, so it's an obtuse one. Do we know about scalene, isosceles, or equilateral, or can we tell anything, Jack?
You have to assume it's scaling.
I have to assume that? Why am I assuming it's scalene?
Because our congruency markers.
How do I know that? Well, I mean, I'm not showing any, but can I tell who's given this information? And so what I want you to thinking about is these are openings, right? So if I open the door 20 degrees, or if I open the door 35 degrees, what can I say about this side opposite 20 degrees? Yeah.
Every side that's the side that's congruent is like the angle's congruent to it. If x and 20 are congruent, then those two lines are congruent.
Well, let's put it this way. None of my angles are congruent. So what does that say about the sides? None of them are congruent either. And it's you kind of have to picture opening the door 20 degrees, right? It only opens this so much. But if you open it 35 degrees, aren't you opening it a little bit wider? So that'll be a little bit longer. And this one you're opening 125 degrees, widest of all. It gets opened the widest. This is actually a scalene triangle. None of those sides are going to be congruent, just for the reason that you were talking about, Jason. So it's really kind of looking at, thinking about it now. Let's see, corollary. What's corollary? Now, I wrote here that it's a statement that can be proved easily using the theorem. It's like a natural follow-up. It follows by what we just said. So a corollary to the triangle sum theorem is one I can easily prove based on the previous one. And it says that the acute angles of a right triangle are complementary. So, you have a question?
So basically the corollary is like the sequel to a theorem?
Kind of. It follows naturally, or it follows easily. And because I know, and I've got some words here, because I know all of them add up to 180 degrees, right? And I know that the measure of angle 3 is 90, so I kind of made that substitution. If you subtract 90 from both sides, you get 1 and 2 equals 90. And it's just an easier way if you're looking for measures. If you know this one, and I know that's 90, I can just say 1 and 2 equal 90. It's just an easier way to find this and that measures. So we've got this corollary. It's a theorem, but it's naturally following from the triangle sum theorem. So let me see if I got this one on here. I think this one I don't. Looking ahead of time, I don't think this one's on the notes. So you can just look up here, and let's see if we can find the value of x and classify the triangle. So first of all, well, what kind of triangle is this? Triangle. Yeah, Amanda?
It's a right triangle.
It is a right triangle. So my corollary says that if you have a right triangle, I can add the acutes, and they're going to add up to 90 degrees. So x plus x is 90. It is not wrong if you do x plus 90 is 180. This is just a little bit simpler. So 2x equals 90. So x equals 45. So my value of x is 45. Each of these is 45 degrees. A little bit harder question is, do I know anything about scalene, isosceles, equilateral? Can I tell anything about this? Or what do you think? Why is it isosceles?
Because the x and x are congruent, and so the two sides are opposite.
And basically, I'm opening the door the same for both. So if you open this door, that's opening it that wide for 45 degrees. You open this door, it's also being wide. And it is true that it is isosceles, and we will be looking at that more, about why this is an isosceles triangle. And it is. If you have two of these congruent angles, you do have an isosceles triangle. This one, I believe, is on your paper. It's on example B on the bottom. Find the measure of angle A and angle C. Because this is a right triangle, that means that these two will be adding up to 90. So I'm going to add those two measures. And I know they're going to be 90 degrees. Let's see, that's 7x plus 6. Oh, we are doing this right. And then I'm going to subtract 6 from both sides. 84. And then I'm going to divide both sides by 7. You should really check my work here. This is where I make my mistakes, doing these little simple additions and divisions and all those things. Did I do this right? Is x equal to 12? Yeah? Okay, so I'll classify the triangle. I know it's a right triangle. And I went ahead and I substituted in those x's. So 3 times 12 is 36. 36 plus 11, that makes this one 47 degrees. And 4 times 12 is 48. 48 minus 5, I think that's 43 degrees. Hopefully these add up to 90. I just like doing those mini checks. It does. Anything I can say about this one? What do you think about that?
Wait, by the way, this might be a bit off topic, but I'm going to earn megabucks. You know why?
What does that mean?
I'm going to earn a lot of money because I just proved the corresponding angles postulate.
Okay, hold that thought for a moment. Hold that thought
No,
for a
you
moment.
don't care. I'm going to earn millions of
I
dollars.
do care about you getting millions of dollars. Believe me, I want to be your best friend if you win $1 million. But I have to just stay on task a little bit. Then I'll talk to you about that in a moment.
Okay.
So it's a right triangle. Do we know anything about sides? What do you think? Yeah, I think it's going to be scalene for the same reason that you said, because none of these angles are congruent. And we're going to talk more about angles next class, about angles affecting our side angle. This is a lovely little theorem. It's called the exterior angle theorem. And it states that the measure of an exterior angle of a triangle, so remember what that is, you kind of extend the side. This is an exterior angle right here. It's equal to the sum of the measures of the two non-adjacent interior angles. So again, we try to state this as most confusing as possible. If this is angle 2 and this is angle 3, they're non-adjacent to 1. And the adjacent angle will be this one. So these are the non-adjacent interior angles. Basically says, if you want the measure of angle 1, just add the measures of 2 and 3. And you'll get the same measure of that one. Okay, all right. Oh my goodness. All right, so 1 and 2 are supplementary because of the linear pair postulate, means they add up to 180 degrees. What else do I know? That means that the measure of angle 1 is 180 minus the measure of angle 2. Okay, so that's what 1 is. I also know that if I add 2, what's going on here? Let me just erase this. If I add the interior angles here, 2, 3, and 4, if I add all those up, that's 180. We already did that theorem, the triangle sum theorem. So let's see, if I have 2 plus 3 plus 4 is 180, I can actually subtract out the measure of angle 2. So what happens is it's gone here, and I get 3 plus 4 equals 180 minus measure of angle 2. Well, 180 minus measure of angle 2 is also the measure of angle 1. So I can use that transitive property or substitution and say that this thing is going to equal that thing, and that's what we're trying to prove. That 1, measure 1, is the measure of 3 plus 4. So, yeah, it's true. So we can do that. So let's just look at a couple of examples. I'm pretty sure this one not on your paper, but just look up for a moment. So this said, if I want to find the measure of angle y, very simply, it's going to be the sum of those two. So y is going to be 88 plus 70, and I think that's right. You just add them. That's it. That's all there is to it. This one I think is on your paper. It's an example C. So we want to find the measure of angle 1, that's this one, and the measure of angle B. Well, basically, we have to find the measure of x, right? The value of x, and then we can find those other two things. How do I set this guy up? Using my new theorem, the exterior angle theorem. Jack?
I use difference in equation for marked angles, angle ACB is y.
Why do you do that?
Because I forgot to read the exterior angle.
Well, how can we do that? There are multiple ways of doing this. You're absolutely right. I know this is 180. It's like you're reproving that theorem over and over again. How would you use the theorem?
76 plus 2x equals 5x minus 2.
That's right, because the theorem says if you have that exterior angle, it's the sum of these two non-adjacent, the one not next to it. Add the other one. And so what do I get here? That's a 3x, right? And that becomes that too, 78. And then I'm going to divide by 3. Okay, I'm going with 26. Can't check my work because I am wrong. This is where I make my mistakes. I'm not up here with the calculator. Is that right? Those of you sitting there with the calculator? Taking my word for it? Yes, we are. Then we have to answer the question, right? It says to find 1 and 2. So angle 1 is going to be 5 times 26 minus 2. Boy, what's that? 20 something. What is it? What?
128.
I heard two numbers. 5 times 26 minus 2. 128. And then what's this one? 2 times 26. I think I can do that. 52. Is that right? I think we found it. Did I find the right angle measures? Gotta check my work here. This is where I'm gonna mess up. Okay, exterior angle theorem. Alrighty, here's another example. I have this as a you try, but we can kind of talk about it a little bit because we're putting together a lot of different things here. Oh boy. So I want to find 1, 2, and 3. Any ideas? What do you think?
You find angle 1 and then use angle 1 before you
Well, first let's find angle 1. How do I find angle 1? How do I find angle 1? How do I find angle 1? Right, the triangle sum theorem states that all the angles add up to 180. So I can add these. And look, there's more than one way to do these, but we're seeing this one. So what's that going to be? Oh, you're the guys with the calculators. Plus that's a 110 equals 180. So that makes the measure of angle 1 equal to 70, I think. So that would be 70 degrees in here. Then what can we do? Yeah? one way to do it. Using our new theorem, I know this whole thing will also be the measure of 45 plus 65, right? So I can actually subtract that from 45. I think that's going to be 65. Right? Because this whole thing is an exterior angle, so it's going to be 45 plus 65. If I know this little piece is 45, then it must be that little piece is 65. Or we can do it exactly what she said. We know this is a straight angle, adds up to that. And then now with this 65 and 20, I can find 3 again by using the triangle sum theorem. So measure of angle 3 plus 65 plus 20 equals 180. Measure of angle 3 plus 65 equals 180, which makes the measure of angle 3 95. So again, we're just kind of putting together the different little theorems that we know about triangles. Make sense? All right, we'll move on into triangle congruence. Triangle congruence. Oh, okay. Let's see. In two congruent figures, all the corresponding parts are congruent. Definition of congruent figures. This is what this is. So if two figures are congruent, their corresponding parts are congruent. Now, what's corresponding part? That's a good question. I'm looking at these two triangles. Angle A corresponds with angle F. That means those measures match. Angle B corresponds with angle E. Those measures match. Angle C and angle D correspond. Those measures match. Now, how do I know those are the matches? 1 arc, 1 arc, 2 arcs, 2 arcs, 3 arcs, 3 arcs. The sides also have to match, so the sides and the angles have to match. This side matches that side, they are corresponding. I see one little mark. AC and FD, they are matches. They have 2 marks. And then BC and EF. So in order to say a triangle is congruent, I have to show all these corresponding parts match. The angles all match, and the sides all match, okay? And when we name our congruent triangles, I do it in a specific order. So see how A and F are the matching ones? I put them together. B and E are the matching ones, they're coming second. And C and D are the matching ones, they come third. Now the order doesn't necessarily matter as long as they line up. If you say A is first, then its match has to be first. If you say B is second, then its match has to be second. And if you say C is third, its match has to be third. I could say it in different orders. I could say BCA, but then if I say B is first, then I have to say E is first, because those are the corresponding parts. If C comes next, then I have to put its match next, which is D. So I don't know if that's making sense. I'm saying it in probably the most difficult way I can think of. But the way you write the congruence is the order in which the pieces match. Same thing with the sides. AB and FE are the corresponding sides. You can tell by just reading the congruence statement. BC and ED are the matching pieces, and then AC and FD are the matching pieces. So I'm pretty sure we are not going to forget corresponding parts of congruent triangles. Congruent, abbreviated to CPCTC. Why he had it backwards, I'm not sure. But CPCTC, if we're saying that corresponding parts of congruent triangles are congruent. So that's how we're going to prove triangles are congruent. So let's identify some corresponding parts here. Let me see. Yeah, we're in the back. And let me see what I'm looking at. Identify congruent parts. See what it says example A. I think that's that one. Yeah? Kind of middle of the page. So the angles that correspond, who corresponds with angle K? Yes. Go ahead. Angle S. How do you know that? 1 arc. Who corresponds with angle L? Somebody other than him must be able to see this, right? And then who corresponds with angle L?
Angle R.
Good. Because 2 arcs, 2 arcs. So they're not necessarily, positioned in the same way. And who corresponds with angle, what's that, J? Who corresponds, yeah, Amy? Angle T. And then now let's look at our sides here. Who corresponds with, I'm going to go with JK. Corresponds with JK. Yes, sir. Go ahead. I'm going to write it as TS. Now, why am I writing? Now, it means the same thing. ST and TS. because JK, look, it went from this angle to the one angle. I kind of want to write them in the same way. Not wrong if you write ST, it's not, but it's just like, okay, I'm being really precise now with the order. How about KL? KL will be congruent to what? Who's everybody else? KL. Yeah, wait. I don't know. KL is going to be congruent to which side on the other triangle? Yeah. SR. What else do we have? That's JK, KL, JL. JL congruent to what? JL. What's it congruent to? JL is Abby? TR. Good. So, now we've concluded the triangles are congruent because all the angles corresponding angles are congruent, and corresponding sides are congruent. So if I write JKL, how am I going to write what is congruent to? Oh. JKL congruent to what? Well, J is the one with 3, so T. K is 1, so that's S. And then L has 2 of them, so it must be R. So the order is helping me figure out what's congruent. I could have written it a different way. What if I started with KLJ? KLJ is congruent to S, where's L? RT. So I'm matching up which pieces correspond when I write how they are congruent. Makes sense or not make sense? So I have one thumbs up. One person's got it.
I'm not gonna sign yet.
Don't tell me if you're yet. Do we get this? Because you guys are quiet. I want to make sure that we're not getting other questions. Okay. All right. So the third angle congruence theorem, how many theorems are there? There's a lot of theorems. So this one, I'm jumping around the page a little bit here. It's towards the top middle of page 2. If two angles of one triangle is congruent to two angles of another triangle, then this third angle will also be congruent. So if A and D are congruent and B and E are congruent, we can conclude that C and F are congruent. Now there's a whole bunch of words here. I mean, can we see why? Why that would be true? What do you think? Yeah, what do you see?
Congruent, then the other one, like those angles, they should add up to 1 for 180, and the other one is like, let's say 30 and 40, then the other angle would be 1 to 10, and so that's 70 and 70, the other angles that later triangles, so the other one has.
Yeah, I mean, that's right. So because these are congruent angles, when you add them together, you're going to get the same sum, right? The whole thing adds up to 180. When you subtract the same sum from 180, you get congruent triangles. Did you want to add something?
Yeah, I was just wondering, is taking a look over the corresponding angles there, have you ever done that?
Well, I'm going to have to wait till after I finish with this lesson, and then I'll come talk to you, okay?
How
I know, I
long
gotta
is
stay on
this gonna
topic.
last?
Okay.
How long is
Properties.
this going to last?
Okay. These are some properties I'm going to give you. Alrighty. So I'm not going to ask you to prove these. I'm going to give them to you. Hey. So we have a reflexive property of congruent triangles. And this seems kind of silly, but sometimes we actually use this property. Triangle ABC is congruent to triangle ABC. Reflexive, right? Symmetric says if ABC is congruent to DEF, then DEF is congruent to ABC. And we have a transitive property of congruence as well. ABC congruent to DEF, and DEF congruent to JKL, then ABC will be congruent to JKL. So I've got a little box on the paper here just kind of summarizing those. If we need them, they're there. So let's see. This was the same example we did, isn't it?
I just don't
Yeah,
understand.
we did this one already. I don't know why that's here. Let me go to the next one. Okay, so I am on example B in the middle of the page. Let's look at this here. I've got two congruent triangles, ABC and DEF. Now what's important to remember here is that I am putting these in kind of an order. So A and D are congruent. They're the corresponding parts. B and E are also congruent, and C and F. So the way that it's written gives us big clues on what's congruent. I also know by my segments. So AB is going to be congruent to DE. So AB is congruent to DE. Now I like doing this markup only because we don't always give you the triangles written in that same kind of orientation. So BC and EF. BC and EF congruent. And then AC and DF. So AC and DF. So now when I say find X and Y, I can match them up. So this one and this one match. So 22, those measures are the same, 5y minus 3. 25 is 5y. Turning it around at the same time, so y equals 5. So I can see that these are congruent once I mark it up. And then this one, AC, matches this one. So I know that 3x equals 9, so x equals 3. So the trick to these is to mark your diagram based on the congruent statement that they give you, so you can match up the corresponding parts. Because corresponding parts of congruent triangles are congruent. CPCTC. Yeah, question? Can you say a little bit louder? The one for segments. If everything else being equal, I would say yes. But not if I don't know anything. Maybe you're right. This one is example C. I want to find the value of x. Cool. Okay, now they didn't tell me anything about congruent. But what do I know, Jack?
Actually, you just use parallel lines.
I don't know the parallel. Do I?
Just because they meet at a single point.
They meet at a single point. I don't know if that means they're parallel. What I do know, though, is I have some vertical angles. So the key with these triangle problems is whatever you know, mark. You might want to say, well, these are alternate interior angles, and since they're congruent, then they're parallel. That's different. But saying because they meet at a point would not be why they're parallel. But they might be parallel. I think you're right. However, I don't even need it because I've got two sets of congruent angles. So what theorem can I use? Yeah? Third angle congruence. So what's x? 65. And if you wanted to use the parallel, you could say because the alternate interior angles are parallel, so these alternate interior angles. I mean, that works too. But we were using the one that we just learned. What else do we have here? This guy here is example B on your paper there. Find x. So again, I've got two matching sets of congruent angles. By the third angle congruence theorem, these have to be congruent as well. So I can set them equal. Whoops, divide. I think I'll divide both sides by 5 first, just seems a little bit easier than doing the distribution. If you want to distribute, you can. 6, we get x equals 2, and hopefully I did that right. Oops, oh, that shouldn't happen. I don't know why that happened. But these things not make sense. So please ask the question if you're like, why are you sending me that? Using the third angle congruence. What else do I have here? Oh, yay, proof. So a proof, the way I'm going to prove them congruent is I have to show all the corresponding angles are congruent and all the corresponding sides are congruent. So they're giving me some givens here. I'm noticing the given statements. AB and CB, great. They're also telling me some of these angles are congruent. This angle is congruent to that angle. This one is congruent to that angle. Those are those givens. Now in here, number 2, it's saying AC congruent to AC. These are why? How come? The reflexive property. Absolutely. Reflexive property. So this is why I'm using reflexive property. It seems like who cares? But yeah, now I've got all my corresponding sides matched. And now all I need is one more angle. And it says angle B and D are congruent. Why is that? Why is angle B and angle D congruent?
Isn't there a reflexive theorem set?
This one, I think they gave it to us as a reflexive property. A reflexive property of congruent triangles, I guess.
It doesn't deal with triangles.
Well, this segment is congruent. Congruent segments, would you rather say that? Okay. Why are B and D congruent? Why is that? third angle congruence theorem. Because these two are congruent to each other, then it must be that these two angles are congruent. Now I can say the two triangles are congruent because the definition of congruent figure states that if all the angles and all the sides, the corresponding angles, the corresponding parts of the triangle, if they're all congruent, you have congruent triangles. So that's a proof example. Okay, then we're going to look at some you tries. I think you can try these. Yeah, I'm going to let you actually try these. We'll talk in a moment. Got what we got here? X is 55, G is 103. G103 is kind of easy, right? Because G and T are a straight match. So G will have to be, the whole thing will have to be 103. And then you just solve this, correct? Yeah? Did you do the other one? You get to this guy here. Can you find the values of X and Y? Did you try this one? Try it. What you should get. So work on that. Still got a couple of minutes. And see if you get the same thing. So we got all kinds of things. Equals 60. And then let's see, WX and QR are going to be congruent. So I can set Y minus X equal to 6.